All right, guys, so here we are in pre-calculus, and we are doing some introduction to trigonometric functions. In Algebra 2 last year, you should have ended the year with some sort of refresher on the trigonometry you learned in geometry, or hopefully a little bit more than that. Maybe you talked more about the unit circle and angles in standard position. Maybe you talked about radians. That's awesome. And if you are coming from a class where you did not do that, you're going to just have to catch up and work hard. So let's get started. The first thing that we need to review is simplifying radicals. Radicals have been a pretty permanent fixture in your lives since maybe Algebra 1, geometry. So let's do a few examples together, and then I will leave you with an assignment of some examples to do on your own. Let's look at example 1. It says over here to fully simplify each radical. Anytime you have a radical in front of you, you definitely want to fully simplify it, not partially. So let's get started. One thing I noticed right away is this 144. I know that 144 is a perfect square. 144 is equal to 12 squared. If I can break this down using a factor tree, I will immediately see 144 times 10. Anytime you multiply something by 10, you just tack an extra little 0 on at the end. That means that the square root of 1,440 is the same as the square root of 144 times 10. That also means, and now this is obviously a much longer breakdown, I'm just really showing you why it is. That means that it is equal to the square root of 144 times the square root of 10. I know what the square root of 144 is. We just said that that is equal to 12. And the square root of 10 cannot be simplified any further. Why exactly is that? Well, if I did the same idea with the 10 that I did with the 1,440, you would see that it is 2 times 5, that makes 10. 2 and 5 are both prime numbers. Neither of them are perfect squares. So there's nothing I can do with that. I can't simplify any further. So our final answer for the square root of 1,440, fully simplified, is 12 root 10. You may also call that 12 square root 10, 12 radical 10. They're really interchangeable. If I want you to type this answer out on maybe a Quizzes or on a Google form, there are shortcut keys that you can make square roots, but since not everybody is really quick with that, and there's more than one square root, the answer key would only recognize the ones that I put in there. I want you to type this answer in the following way. If you had to type this, you would write 12, then you would write SQRT, all lowercase, parenthesis, 1, 0, close parenthesis. So square root, that's the notation. Ironically enough, you also use this exact same notation when you are typing square root out on Desmos, and the square root symbol will pop up automatically. The parenthesis is to really tell you what goes under the radical, or the square root symbol comes after this parenthesis and ends before that parenthesis, because you might have more stuff later on. Okay? So make sure you make a note of that for yourself as well. And you could break this down with more of a factor tree and keep going, but if you know 144 is already a perfect square, 12 times 12, we really could just take it from there. Let's look at example 2. In example 2, we have 2 radical 6 times 3 radical 3. When you're multiplying radicals like this, what you need to do is as follows. The 2 and the 3 are coefficients in front of these radicals, so they are going to be multiplied together because they are like terms. Then the square root of 6 and the square root of 3, they are both square roots, so they will be multiplied together. This is sort of like the reverse of what I did right here. 144, 10, and I now want to put it together. Trick, pointer, advice, don't actually multiply 6 and 3. I would continue breaking down whatever number in here may not be prime and find out if I have any perfect square in them. Because what if this were 61 and 35, whatever? Do you really want to multiply them first when you might, or well, maybe not 61, but maybe 65 and 35? I don't actually want to multiply those. If I know they're both divisible by 5, that means I'll have a 25, which means a 5 can come out because the square root of 25 is 5. So let's keep moving. 2 times 3, hopefully no issues with that. That's 6 right there. Now, this square root of 6 and 3, I'm going to write 2 times 3 for that 6 right there, and that 3 is just a 3. 2 is not a perfect square, but 3 times 3 definitely is a perfect square. I have 2 of them. 3 times 3 is 9. I don't even care that it's 9. I don't need to write it down. I just know that 3 times 3 is a perfect square, and the square root of 3 times 3 is 3. So that means 6 square root, 2 stays inside. 3 times 3 is 9. Square root of 9 is 3. That comes on out. Now we don't add it to the number on the outside. You multiply. This whole thing is one big product. So 6 times 3 is 18. And we're left with 18 square root 2. And the way you would type that is you would type 18 SQRT, all lowercase, parenthesis 2, and close parenthesis. And that's the end of example 2. Example 3 is not multiplying this time. We have sums and differences. Sums are addition, differences subtraction. You can only add and subtract like radicals. I would not be able to add square root 6 plus square root 3. They are not like radicals. I could add 2 square root 6 plus 3 square root 6. That would end up being 5 square root 6. So the square root 6 is sort of like an X, or bananas. 1 banana plus 5 banana, 6 bananas. I'm going to rewrite anything that's already simplified, and I will simplify anything that isn't, so I could figure out if I have any like radicals. 2 square root 6. Square root of 6 cannot be simplified. There's no perfect square, so it's going to have to stay as it is. The square root of 24, however, well, that is a little beefier of a number, so we can probably break that down a bit. What multiplies to give us 24? Some of you might immediately jump to the perfect pair of factors where the largest perfect square is there. Others may not. So if you have to make a factor tree, make a factor tree, but you got to be quick, you got to be efficient, you got to keep it moving. Plus 3 square root of. All right, what is in 24? If 24 was on the shelf at the grocery store and you looked at the ingredients label, what's inside? It's definitely even, so it's 2 times something. 2 times what? 12. But what's 12? 2 times something. 2 times what? 6. But what about 6? 6 is definitely 2 times something. 2 times what? 3. So by doing this, 2 times 2 times 2 times 3, I really have 8 times 3, or I have 4 times 6, or I have 6 and 2 is 12 times 2. I have made the prime factorization of 24. I can see exactly what makes it up, and I can find the largest perfect square. 2 times 2, 4, and the square root of 4 is 2. So that 2 right there is going to come on out in the front, and the other 2 and 3 will stay inside the radical. 7 radical 5, well, we can't do anything with that, but it will already combine with the first radical 5. So here we go, 7 radical 5, and I'm about to combine that in the next step. How much radical 5 do I have right here? 1 radical 5. 7 radical 5. How much do I have altogether? 8 radical 5. Minus 2 radical 6 plus 2 times 2 was 4. The square root of 4 is 2. So whenever you have a pair of numbers, one of them is the square root, and that can come on out of the square root. 3 times 2 is going to be out front. 2 times 3 is all that's left inside. We just said that that would be, and that is 6. 3 times 2 out front. So we have 8 square root 5 minus 2 square root 6 plus 6 square root 6. Now I have a negative 2 square root 6 plus 6 square root 6. -2 of them, and a +6 of them. How many of them do we have? 4. 8 square root of 5 plus 4 square root of 6. There we go. Maybe I should have some equal signs out front for you. Now, how would I type this guy? Order doesn't matter. 8 root 5 or 4 root 6 could be in front. That doesn't matter. It's interchangeable. I will have 8 SQRT parenthesis 5 close parenthesis plus 4 SQRT parenthesis 6 close parenthesis. I hope you got that all copied down. And let's just look at 4 more examples. Here we see that radicals may appear in our denominators, and that is a big no-no, definitely not allowed. So how do we take care of this situation? A lot of people may want to jump right to rationalizing the denominator, but it's definitely not the most efficient or necessary thing in this example. On the previous page, we saw something like this. The square root of a product is equal to the product of their square roots. The same is true for a quotient. The quotient of 2 square roots is actually equal to the square root of that quotient. Now, am I making this better by putting one giant square root over the whole entire fraction? Actually, in this case, I am. 40 over 5, or 40 divided by 5, works out pretty nicely. We just have an 8. Now we no longer have a radical in the denominator because the denominator was 1, or radical 1, and the square root of 1 is 1. So no need to write that down. Now 8. The square root of 8 is definitely one that you should memorize and know by heart. So if you know by heart that it's 2 rad 2, amazing. Keep that up. Don't forget it. If you didn't know it by heart, make it a mental note to memorize that. And to just show you again how it's broken down as a refresher lesson, 8 is the same as 4 times 2. And I could even keep going. 4 is 2 times 2. So we have 2 times 2 times 2. 2 to the third is 8. By knowing these math facts very quickly, you'll actually keep yourself motivated and moving along really, really quickly and feeling good about the problem. Whenever you have 2 of something, that means it's a perfect square. So 2 times 2, perfect square. The square root of 2 times 2 is 2. So we have 2 square root 2, and that is the final answer. And how would you type that out? You would type 2 SQRT parenthesis 2 close parenthesis. And that's all there is to it for that particular example. But you may ask, well, what do I do if I can't get rid of the radical in the denominator like that? What if that trick of yours doesn't work? Well, then we have to rationalize, like in example 5. So that radical 7, annoying little guy, can't be simplified. I can't clean it up anywhere. We need to rationalize. There is something called the multiplicative identity. The multiplicative identity is the number you can multiply anything by and not change its value. Do you guys know what the multiplicative identity is? The number that you can multiply anything by and not change its value is 1. Now this 1 isn't really going to look like a 1 when we multiply. It's going to be a sneaky one. So the 1 is sort of going to be hidden because we're actually going to multiply by square root 7 over square root 7. Anything divided by itself is 1. That's no different. Now, what do I get in my numerator? Well, 3 times square root 7 is just 3 square root 7. Nothing to do there. In my denominator, I have 2 times the square root of 7 times the square root of 7, which is the square root of 7 times 7. The product of 2 square roots is the square root of the product, but we know what the rule is. The product of a number and itself creates a perfect square, and the square root of 7 times 7 must be 7. That really means we have 3 square root 7 in my numerator and 2 times 7 in my denominator. And what is 2 times 7 equal to? 14. And that's the answer. The 14 and the 7 cannot reduce. You cannot reduce a number in a radical with a number that is not in a radical. All right? How would you type this answer? Now here we're getting a little bit more involved. Here we would type 3 SQRT, all lowercase, parentheses 7, close, slash 14. Since I only have one term in my denominator, I don't need parentheses. However, if I had 14x in my denominator, I would need parentheses for that example. Let's check out example 6. It's actually very similar to example 5. The only difference is my numerator has a difference. Get it? Difference? So the main difference is there is a difference. We need to get rid of the square root of 5, and we can use the exact same approach we just did. We're going to sneak up and multiply by 1, but we'll disguise it by calling it square root 5 over square root 5. When you multiply this to the numerator, we need to remember everyone's favorite property, the distributive property. Square root 2 times square root 5 is square root 10. They are both under a square root. We can multiply those numbers underneath one square root symbol. 3 times square root 5 will look like this. It's 3 square root 5, nothing to do. But square root of 5 times square root of 5 in the denominator is the square root of 5 times 5. And the square root of 5 times 5 is the square root of 25, which is 5. Again, you don't need to write down square root of 25. We could just go right ahead and write down that 5 right there. Now, how would we type that answer? Parentheses are going to need to be involved. We will need parentheses around the whole numerator to indicate that the entire numerator is being divided by 5, not just the last term. Otherwise, that's what it will look like, okay? So I'm going to start it under here a bit. We will have SQRT, parenthesis 10, close, minus 3 SQRT, parenthesis 5. Now that's the numerator if it was on its own. Since it's all dividing, it actually needs a parenthesis around the entire thing, slash 5. And we don't need that parenthesis around the denominator because it's only one term. So the way you would type your answer is just like that. But when you write your answer, this is perfectly acceptable. Now, your answer to a quadratic formula problem, if you remember, sometimes looks something like this. You might be able to reduce pretzel style, meaning reduce this and reduce this. However, my coefficient here is 1, 3, 5, nothing to reduce. And I have radicals there and none here, so nothing to reduce. And I call it a pretzel because if you draw those ovals, it kind of looks like a pretzel. But we'll see some pretzel action in the future. All right, last example is example 7. Here, my denominator still has a radical similar to the examples before it, but multiplying by radical 5 is going to put you in a bit of a catch-22 situation. So you'll clean up that one, but you're going to put one there. It's like whack-a-mole. And then you clean up that one in the next step and you put one there. And it's like back and forth, back and forth. So we're supposed to use something special. It's a word you may have heard quite a few times. It starts with the letter C, and it's got 3 syllables. Does anybody remember that? The word I'm looking for is conjugate. Think about your foreign language class. When you conjugate your verbs, you keep the beginning and you change the ending. So the conjugate will be 3 minus 3 square root of 5. This times this means we have to use a famous acronym And that famous acronym is FOIL. First, outer, inner, last. We have to multiply with distribution. However, because they are conjugates, when you multiply, the OI in FOIL is going to cancel out, become 0. And we will be left with first times first and last times last, which is actually some other acronym, DOTS, the difference of two squares. Hopefully this all rings a bell. But we can't just multiply in our denominator as we just saw with our previous examples. So we need 3 minus 3 square root 5 in my numerator as well. That is 1, and 1 is the multiplicative identity. The number you can multiply anything by without changing its value. Now, 4 times this numerator is just some basic distributive property, but I'm not going to distribute it right away. Let's sort of just let it hang out for a moment. 3 minus 3 square root 5. I actually could factor out the 3 and make this 4 a bigger number. I like to factor things whenever possible because when things are factored, it's a lot easier to reduce, and we always want to try to reduce. First times first is 9. Outer is minus 9 root 5. However, inner is plus 9 root 5. Please don't waste your time. That equals 0. Adios, goodbye. Last times last, and this only happens when they're conjugates. Last times last will give us a positive times a negative is negative 3 root 5 times 3 root 5. 3 times 3 is 9. Root 5 times root 5 is 5. 9 times 5 is 45. And I'm also going to factor out that 3 and multiply it out front in the next step. So what do we got? Equals 4 times 3, 12. When you took the 3 out, we are undistributing it. So you're doing the inverse of multiplication, which is division. This does not become a 0. 3 divided by 3 is 1. So you have 1 minus radical 5 over 9 minus 45. And what is 9 minus 45? That equals negative, because we have a small amount of a positive and a lot of a negative. Negative 36. Conveniently, 12 and 36 will reduce. 12 and 36 will reduce and leave me with a 1, which I don't need to really write down, and a 3, but that negative is still there. Now I could actually reduce this negative with these two things right over here. So I'm going to write this answer two different ways. Let's do a little loop around so I have some more space. 1 minus square root 5 over negative 3. But we really shouldn't leave a negative in the denominator, just like you shouldn't leave a radical in the denominator. So let's take a look at that pretzel I mentioned before. I can divide the negative into the 1, and I could divide the negative into the negative radical 5. What will happen if we do that is we will have a negative 1, and we will have a positive square root 5 over 3. However, a textbook or answer key probably wouldn't leave the answer like that either. And instead, your answer would put the positive term in front, square root of 5 minus 1 all over 3. So I think most traditionally, the answer would look like this. So if it were multiple choice, you'd have to find the correct answer, and it doesn't always look exactly like what you had on paper. But when it is open-ended, I guess there's a little bit more flexibility there. Now, how would you type this answer? So I'm going to have to squeeze it a bit, but let's see what we could do. Again, I want parentheses around the whole top. SQRT, parentheses 5, close those parentheses, minus 1. If you didn't use parentheses, it's going to be 5 minus 1. Maybe you meant 4 because 5 minus 1 is 4. Am I allowed to combine those? Should the parenthesis have been here? You know? So you want to be clear. It's just the square root of 5. Take away 1. Divided / by 3. Again, sorry it's a little squashed, but hopefully you follow along with that. And that's the end of example 7. So on your own, you are going to work on the matching practice assignment. Well, it's not matching, like you don't match things to each other for the assignment. It just matches what we're doing, sorry. The practice, you're going to do the practice assignment, which is numbers 1 through 19. And I will have that worksheet shared for you, which you can print out at home and work on, or you can look at and write in your notebook. And in either case, the picture of these notes, examples 1 through 7, will be attached to your virtual notebook, and your written work for your homework will also be attached in your virtual notebook for our class date. I hope you understand this. If not, give the video a thumbs down. If you do, give the video a thumbs up, but maybe wait until after you try the practice assignment, and then be sure to ask lots of questions as you need help.